Hello everyone. So today we have a presentation on quantum computation, and there will be few other things that I will be talking about today. So for the brief, here are the content that I will be discussing. First, we will be learning about what is quantum computation. Then we will learn about qubits. What are qubits? They are the building blocks of quantum computing. So we'll learn about them, and then we'll learn about quantum gates and how we do operations on qubits and how we form quantum gates. And then we will see the advantages of quantum computing, and then we will recap all the session and talk about the key takeaways that we can take from the session, and then we will be discussing each other or asking questions. You can ask me questions related to quantum computing and etc. First of all, let me introduce myself. I am Shreya and I'm currently doing my masters in quantum technology from UIMP Spain. And so therefore I feel like I'm qualified to tell you what is quantum computing because I'm doing masters in this subject. So first of all, what is quantum computation? Quantum computation is basically a type of computation that or a computing that we do, but it is different from the computing that we do in our laptops. Like normal day to day tasks that we do use are using a computer, a phone. So that is what we call classical computing. But now there is new thing which is quantum computation. It is different from classical computation because this is the one key takeaway that you can take from the session, that unlike classical computers that uses 0 or 1, like either it will be 0 or either it will be 1, but in quantum computers they use qubits. What are qubits? They are quantum bits, but these qubits can exist in multiple states at one, which means I have a very cartoonish diagram with me to understand this. So in this classical world we have a cat which is alive or the cat is dead, but in quantum world we have a cat which could either be alive or either be dead, but we don't know yet. In quantum computation what happens is that we use this advantage of having two states at one time, and we use this advantages in the computation, and that the computation is called quantum computation. So it is a revolutionary way of processing information. And why it is called quantum computation? Simple, because we use the principles of quantum mechanics. Later in the session we will know some what are these principles, but right now just stick in your head that there are principles in quantum mechanics that we use in computation, and therefore we got quantum computers. So now I was telling you what is quantum computation, but let's see what is actually the difference between classical computation and quantum computation. So, as I told you before, that classical computation had bits 0 or 1, but in quantum we have qubits, which can be 0, can be 1, or can be both. In this diagram, you can easily understand what I am talking about. So, this is one of the quantum properties that you see, which is superposition. What happens in superposition is that you have 0 and 1 together in one state. This is classical setup where you had 1 and 0, two different type of spins, but in quantum you have a superposition where you have 0 and 1 together. Now in classical computation the information process happen linearly, but in quantum computation we have the property of quantum mechanics which is superposition, and we use this, and by using this we can do parallel computation as well. In classical computation we are limited by the Moore's law, but in quantum we can solve problems exponentially faster as compared to the classical counterpart. Now for classical computation we have a laptop, smartphone, we can use it anywhere anytime with the internet connection, but in quantum computers we only have quantum simulators which act like quantum computers, but they are not real quantum computers. And then we have future quantum computers. The quantum computers that we have right now are not perfect. They are not as perfect as your classical devices. So we are in an era where we have quantum computers, but they are not perfect. So we are saying that okay, but we are working on it. So future we will have quantum computers. We will solve problems, in ideal conditions. But right now we are working on it. Now we have why quantum computer is a game changer. Like, why should you bother to learn about quantum computing? Because you are using your classical computation, you have no problem in it. Then why we have to use quantum computer? The first very important advantage that we get from quantum computer is exponential speed up. The algorithms like Shor's algorithm, Grover's algorithm, these are the algorithms that are the reason why we are looking in this quantum computing regime, because these algorithms are very important. So let's see. So Shor's algorithm is a quantum algorithm for finding the prime factors of an integer. You know, we can easily find prime factors of integer, that's not a big deal. But when you have a large number and then you have to find the prime factors, then it becomes complicated. The whole internet security is actually depending totally dependent on this prime factorization of an integer number. So Peter Shaw discovered an algorithm which can solve these prime factors very fast. Like, as compared to a classical computer, it can solve it very very fast. And therefore it may cause trouble to our encryption and the data we have in the bank accounts, etc., etc. So we will be able to compute and solve this very complex computation problem using quantum computer. And therefore it is very important that people should have governments should have access to quantum computers, and they should know how to fight against these algorithms, because these will be able to fight against these classical algorithms which we work on right now. Now the second advantage is beyond classical limits. Quantum computers, this can solve problems which are basically impossible for classical computers to solve. For example, we have Willow. It is a quantum chip made by Google this year. It is launched in this year only. So you know what they are saying? They have set a benchmark computation in under 5 minutes. That would take our supercomputers to you can just see it 10 septillion years to solve that problem which will take these many years to solve, can be solved in 5 minutes using the chip that quantum this Google is developing. It's called Willow. You may search it online, you can find many resources related to it as well. This is Peter Shaw who made the algorithm, Shaw's algorithm, which is a breakthrough, to be honest. Now, there are many other opportunities in this quantum technology that we have not discovered yet. We are still researching on it and trying to find how we can use the power of quantum computation in it. First of all, is drug discovery. So, in drug discovery, what we have is a very large data set, and it is very difficult to compute on it. So when you have a very large data set, it becomes complex to do the computation. But here comes the advantage of quantum computers. These computers are very good at heavy calculations. So for simulating molecular interactions, quantum computers is a need. And for cryptography, breaking the classical encryption that we talked about in Shaw's algorithm, to enable quantum safe cryptography, we need quantum computers. For optimization, I just took these articles. So this is recently, a very good example of how ISRO has also used quantum communication for space communication. So they use quantum keys and encrypted signals and send these signals to space, and they communicated using quantum communication. So it is also a very futuristic technology, and many space agencies are using it and they are experimenting on this. Similarly, on drug discovery, you may find many internet resources on it. People are working on it, and they are figuring out how you can, use the quantum computing in early drug discoveries. And then we have an amazing problem that quantum computer can solve, which is optimization. It can solve complex logistics and supply chain problems as well. This is a photo that I taken from a research paper article. It says that we can use quantum to figure out the best solution possible for the logistic problems. So there are so many application coming around related to quantum computation, which is very interesting and important to see. So as teachers, you must know about it, so that you can make students aware about it, so that the students can look forward to these fields and work on these fields. Similarly, to students, this is a very futuristic technology. People are working on it, researching on it, just like artificial intelligence. Quantum computing is a latest technology, and it will create employment, and government is taking initiatives. So you should look for these fields which are good, research oriented, and which will be the future of the world. So then I have other plans as well. So this is for now. Then we will be discussing about qubits and quantum gates and advantages of quantum computing in details, and some key takeaways. So thank you so much.